we have this function f of x and y is x cubed minus 3x squared y plus y cubed. This is one of the functions that we looked at in a previous video in this playlist, where we saw that it was a homogeneous function. Now, you can see, if you're not asked or required to test it to see if it's homogeneous at first, right? You can see here that we have 3 x's, 3 variables here, so the power is 3. We have 2 x's and 1 y, so the power is 3. We have 3 y, so the power is 3. So it is homogeneous with degree 3. Now, of course, you might be required to show that it's homogeneous before you verify Euler's theorem on it. Let us do that. F of lambda x, lambda y, where lambda is a positive integer, is going to be lambda x cubed minus 3 lambda x squared lambda y plus lambda y cubed. So what we have here is lambda cubed x cubed minus, it's going to be 3 times lambda squared by lambda is lambda cubed x squared y plus, this is lambda cubed y cubed. When we factor out lambda cubed inside the bracket, we get x cubed minus 3x squared y plus y cubed. So this is lambda cubed times f of x y, because this is f of xy, the same thing as this, right? So you can say it is homogeneous. If you're not sure, you test it and show that you test it, that you verify that it is homogeneous. Now we want to verify Euler's theorem on it. Let's just remove the verification here, and then we look at Euler's theorem. What was this Euler's theorem business all about again? It says x delta u by delta x plus y delta u by delta y is equal to n u. Remember, u is a function. Alright? The function is u. Now, here we have u is equal to x cubed minus 3x squared y plus y cubed. Delta u by delta x, because we want this part what says delta u by delta x, we want to find out what it is. It is going to be 3x squared minus 3 by 2, 6 x y. This part goes to 0 because this is just a constant. We are treating y as if it is a constant for now. After that, multiply by x. You have x delta u by delta x is equal to, this is going to be 3x cubed minus 6x squared y. Alright? Now what about delta u by delta y? Delta u by delta y is equal to, differentiate it with respect to y. This will go, it's 0, it's constant. We're treating x as if it's a constant for now. You're going to have minus 3x squared plus 3y squared. Alright. Now we want y times delta u by delta y. So we multiply this by y. Y times delta u by delta y is equal to, multiply this by y. is going to be negative 3yx squared plus 3y cubed. Let's rewrite it and put the positive part in front. 3y cubed minus 3y x squared, or 3x squared y. Let's put it in alphabetical order. 3x squared y. Alright, so that's what we have there. Now we're going to add them. X du by dx plus y du, I mean x delta u by delta y plus y delta u by delta, what did I say? X delta u by delta x plus y delta u by delta y. That's what I should say. Alright, so x delta u by delta, let me rewrite that. X delta u by delta x plus y delta u by delta y is equal to, what is it equal to? Well, this is 3x squared minus 6x squared y. So we have this, alright, plus, I mean this, plus 3y cubed minus 3x squared y. Alright, so what happened here? Let's put the x's together and the y's together and so on. This is going to be, well, we have 3x squared, the x squared y part, minus 6x squared y minus 3x squared y plus 3y cubed. So this is 3x squared minus 6 and 3, 9, 9x squared y plus 3y cubed. Alright, can we factorize this? Yes. If we put 3 outside the bracket, we have x squared minus 3 into 9, 3 x squared y plus y cubed. Alright, so this is x delta u by delta x plus y delta u by delta y. Alright, see what's going on here. This is x squared minus 3x squared y plus y cubed. This is x squared minus 3x squared y plus y cubed. Okay, so this is u then. So what we have then is that x delta u by delta x plus y delta u by delta y is equal to 3u. That is what Euler's theorem says. So Euler's theorem applies to this. So this was verified.